Good morning, good afternoon, good evening, everybody. Welcome to the Parasoft webinar today, making your C and C++ applications safe and secure with MISRA and CERT. We're broadcasting this in several time zones and we'll be rebroadcasting it even more, so we welcome everybody and thank you for your time. My name is Arthur Hicken. I'm the evangelist at Parasoft. With me today is Ricardo Camacho, who is a product marketing manager for our safety and embedded application. So before we get too deep, I want to just cover a couple of Zoom user tips. Your microphones are turned off. You can't join, you can't share, you can't do anything, any Zoom bombing of us. We do have a Q&A box. You can ask questions. There's also a chat box. Use the chat box if you need to get attention. Maybe you're having trouble with audio or getting something working. If you have a question about the topic, please put it in the Q&A box and we will get to it and let everybody know the answers. So it's really great that way. And as always, we will mail you a link to the recording and slides after the webinar is over. So don't worry, we'll have it available for you. So today on the agenda, we have a couple of different things. What I like to call the 3 S's: safety, security, and standards. We're going to talk specifically about CERT, about MISRA. We're going to show you how it works in the IDE, what really happens, and then the 3 R's: managing results, risk, and reports. So as we all know, everything has changed in the way that software has become embedded in everything. Software quality often affects safety critical things. There's a lot more complexity than there used to be. It used to be that simple systems inside of a car, for example, might have a couple hundred lines of code. And now they have millions, even up to 100 million. It's no longer practical to manually audit or review every line of code. And the threats of failure and hacking involve human life. So it's really important that we get the software right, that it behaves properly under stress and under attack. We can't simply treat QA the way we have in the past. We can't say, hey, this is a hardware problem. The software's simple. We'll look at it and everything will be good. And so that's how we want to look at these things. Now, as probably everybody who's attending this knows, C and C++ are thriving in the embedded space. Some people thought these were kind of dead languages, but we can see that they're used very, very heavily. And I often see that these smaller devices with less code and less logic on them have C, or maybe they're timing and performance driven. And C++ tends to be on the devices that require a lot more logic or user interface. And C++ is growing as well. But it's pretty interesting to see that these languages that, 5 years ago people thought were really on a downward spiral are really growing again. And I like this bar group embedded survey. They put it out every year or two, and it's got some fascinating stuff in it. But they show what are people doing, and this shows a couple of different years. So light blue is 2017, dark blue is 2018, and green is also 2018. So you can kind of add the two together for a total. So we do say it looks like, if you just look at blue, that things are getting worse. They're actually getting better, but what happens is, in 2018, people started doing things, but they're not really enforcing them. And in particular, I'm a little confused about the fact that people are doing static analysis, but without some enforcement, and people are doing coding standards without static analysis. And if you have 200 lines of code, I guess that's possible. But if you've got 1 million lines of code, it's not. Even if you have 50,000 lines, it's probably not. So kind of weird. We also wanted to point out today, because we're talking about safety and security, and there is a lot of overlap in what you do, but the standards aren't necessarily the same. And so we look at, again, the BAR's embedded survey, lots and lots of people using MISRA, using Joint Strike Fighter, using high integrity C. These are great safety standards. For the most part, they don't have much in the way of security in them. MISRA does have a security addendum, but it's certainly not as rich as a secure coding standard is in that area. The other thing, you see I put 2 question marks here about proprietary. Like, why in a modern age are you making up your own coding standard? That just doesn't make any sense anymore. It might have, again, 25 years ago, sure. Today, there are great standards out there like MISRA that we're going to show you, and CERT, that have a lot of maturity and a lot of research behind them, and you probably can't do a better job. And then other, like, what are you using if you're not using one of the big ones? Kind of crazy. If you are using a weird one and you want to let us know, like, feel free to put it in the chat of the QA box. I'd love to know. So the thing about safety and security is that they're both a weakest link problem. I think of it as a Death Star problem, right? You have this big, massive, impenetrable safe system that, you can't come, you can't drop bombs on it, you can't bring big fleets and attack it. But there's this one little tiny weakness, this little requirement, don't worry about it, it'll never happen. And the problem is that that's all it takes, right? Everything in modern systems like cars is interconnected. So once you get this little tiny hole in the system, things can go horribly, horribly wrong. And that's what I talk about when I say one weak spot is all it takes. You really don't want your system to blow up. So I like to look at what are the kinds of ways that this is a security example, but we have the same thing with safety. Like where are the failure points and the threat access points? How do people get into these things? And it's funny because it's literally everywhere now, again, because everything is interconnected. So I could come into a system through an MP3 player by putting a malicious payload in the middle of an MP3 file and end up taking over interesting parts of the car. And again, failure modes show how things are interconnected in funny ways. And, everything's on a bus now. Back in the, deep, dark ages, cars, for example, had a switch, and the switch led directly to the thing that it turned on and off. Now you put a message on the bus and it picks it up. And in some sense, cars and high-end applications and embedded monitors in hospitals and things like that all look exactly the same from an architectural perspective. They're connected to a bunch of services, they pick up messages off a bus, they send messages to the bus, and off they go. And so I think about what can happen, right? I might not worry about a door lock, but if it turns out that the door lock can lead to the engine being stopped during running, then maybe I do worry about it. So the interconnectedness is really a problem. And I actually have a funny story about how little things can cause problems. So this is the brake layout of an old Jeep. And I used to have a Jeep Cherokee Chief wide track. And there's this little tiny spot where the brake line, instead of being metal, wraps around the front shock, and the front wheel, that wheel actually turns left and right because that's how you steer the car. Now, the hose that's there is pretty long and has this metal protection on it. So it's a better Jeep than mine was because mine looked more like this. And in fact, that hose was wrapped around the shock in the wrong way. So it was too short. So that when the car steered too far in one direction, that little tiny hose, out of all the many, 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 many feet of brake line, brought the whole system to its knees as a single point of failure. Purely mechanical. And lucky for me, it was a big snowstorm, and I just slowly drove the vehicle into a snowbank to stop it. But again, some small, simple thing can lead the whole system to failure. And that's the point of coding standards. It's funny because in the software world, we've gotten all too used to thinking of coding standards not in the same way that we think of electrical engineering standards or mechanical standards. We think of them as suggestions. Or we often think of them as ways to find bugs, and we deploy dynamic analysis tools and static analysis tools as a testing methodology, hoping to find bugs. But if you look at the MISRA guidelines, they were written not to find bugs so much as to address potentially unsafe language features. So you might find code that is completely legal, the compiler will handle it, it's correct code, but it's simply a bad idea if you're worried about safety, reliability, performance, security, etc. And that is the point of coding standards, is not so much to do early detection of bugs, but to produce better code that isn't vulnerable to these kinds of problems, to reduce the attack surface, to reduce the risk the inherent risk in the system. And then these other tests tell you when something's wrong. And again, when we think about standards, the point is that we start to build things in uniform, proper ways. This car would probably function, but would you buy it? And ideally, even from a security perspective, we're trying to prevent the "you've been hacked, you've been taken over" problem from occurring. Now, there are a lot of coding standards out there, a lot of different things, and it seems like new ones are still popping up. And of course, you know, that's what happens when there's too many coding standards. The answer is, well, let's make another. Actually, I put this up because it cracks me up because it is all too common. But I have seen a trend over the last 3 or 4 years where people are trying to reuse existing standards, less, you know, let me make my own proprietary standard, or let me start an organization and build an entirely new standard. And so we'll talk a little bit in a few months, Ricardo. We'll talk about like the combining of MISRA and AUTOSAR. We saw this with Underwriter Laboratories with UL 2900, cybersecurity for connected devices, where instead of creating a whole new standard, they are building on top of CWE and OWASP. One important thing to know, again, we're talking here primarily today about safety and security. We presume for most embedded people that quality and reliability are also an issue. There's a lot of different research on these topics, and what we find out is that safety, security, reliability, quality all go hand in hand. You can actually predict problems based on traditional software defects. And we see this in C and C++ applications because honestly, the most common coding mistakes that become defects in the software are things like numeric abuse, integer overflow, recently found in modern aircraft. I'm not talking 20 years ago, I'm talking last year. So buffer overflow, underflow, memory corruption are the most common problems. And these aren't specifically safety problems. They're not specifically security problems. But if you fix the code, you're improving all of these categories. And so that's really the upside to all of this. Building better code is building better code. You don't have to worry about, okay, well, I'm going to improve the safety or the security, but I've still got a quality issue. No, you're fixing everything all at once. And that's the really great thing. So with that, I want to show you a little bit about CERT. If you're not familiar with it, the Software Engineering Institute works with CERT to create these secure coding guidelines. The people at Carnegie Mellon, I've done some webinars with them. If you want to watch one, there's a pretty good one that we did last year, the year before. Basically, it's developed with community involvement. You can go to a URL that'll give you in a moment, and you can participate. You can recommend new guidelines. You can edit the examples there, look for changes, make fixes. But the cool thing about the CERT guideline is that it's really focused on engineering and prevention. So again, there are guidelines there that say, hey, look for this thing. But a lot of the guidelines are around build the code in such a way that a particular thing can't happen. So it comes out, there's a lot of static analysis rules. We're talking today about C and C++, so I do want to point out that CERT in particular supports Java, Perl, and Android as well. They have two categories. I'll talk more about that in a moment. And they have some really cool risk scoring mechanisms, which help you understand what do I need to work on first. And again, I'll dive more into that in just a moment. These two types of guidelines in CERTs are rules and recommendations. And basically, the rules are the ones that are required because a defect is likely to affect safety, reliability, or security adversely. And you can't rely on random assumptions in the code. And in their case, rules are ones that we'll see a similar logic in MISRA. Rules are ones that can be checked for conformance through automated analysis. In other words, they are what MISRA might call decidable. So I can run a static analysis tool or some other thing and say, I know that this is being followed. Recommendations are things that are either less nasty or there's just no way to use a tool to really be certain that it isn't there. So there's a wiki. The bottom link is the shorter one, securecoding.cert.org. You can get there. It's the latest. There is a PDF. It's from 2016. A lot of people like to talk about CERT 2016. There's not really a CERT 2016. There's a 4 years ago, CERT happened to take the entire wiki and put it into a PDF. I presume it's a relatively nasty, painful process for them because they don't update it very frequently. The point being that the guidelines are constantly changing and growing, and so whatever was done in 2016 at this point is way out of date. There's probably 40 or 50 guidelines that don't exist. Many of them, for example, around threads and things. So if you're looking at tools, make sure that they support the entire up-to-date CERT guideline as listed at securecoding.cert.org and not the 2016 guideline from 4 years ago that was just downloaded on a particular day in 2016. It's not an actual, see, OWASP has years, CWE has years, CERT doesn't. Okay, so just something to remember. So again, you know, on the right, we see an entire guideline at the CERT website. I wanted to just go through what these little sections are. At the top, you have actual categories, things like declaration and initialization or miscellaneous or threads or POSIX, etc. So the categories are helpful because you understand what kind of problem it is. There's numbers in there. The numbers help you determine whether it's a recommended or a rule, even if you're not looking at, this one is recommended. You see it says Rec 01 at the top by the title. And then you get an introduction and some normative text. What is this? What does it mean? So that you understand it a little better. Next, what I get is an example of what, you know, code that isn't compliant looks like and what code that is compliant looks like. So now I can better understand what does it really mean, because the description sometimes gets a little vague and hard to really grok. The cool thing is down near the bottom, we get some related guidelines. Again, I've mentioned there's a lot of standards out there, and we see, for example, in this one that this is a C++ guideline, but it has a related C guideline that is also maybe applicable for you. There's a Java guideline that conceptually does the same thing. There's a CWE guideline, CWE 369. And then down at the bottom, you see a bibliography. So if you want to understand why is integer overflow important to security, maybe you don't know that, then you can go read that by C-Cord there, apparently. So some good stuff for further information, further training. And then there's this cool thing about risk assessment. Again, I'm not going to get too deep here, but basically CERT uses severity, likelihood, remediation cost together to determine priority and level. And also there's a section for tools to self-certify. So these aren't proven, they're vendors like Parasoft showing you what things are done. So at any given moment, you can click that Parasoft C++ test at the CERT website and see what are all the checkers that we have to support which guidelines and what are the checkers named. So a couple of cool things there. One, every guideline that is decidable, in other words, can be checked with a static analysis tool, we have a checker for. And we named our checkers in this configuration so that they match the guidelines. So it really makes life much easier for you. See, this rule is called POS 53-C, which is a POSIX rule. And the checker is CERT C, so that's the package that it's part of, and it's POS 53-A, implying that there are probably several different ways that this thing can manifest itself. So we have some letters to help define that. So that's part of our mapless standard-centric methodology, and you'll see that more as we go. I did want to cover a little more on that risk before we move on. I said that there are three values that CERT uses: severity, likelihood, and cost. And you can actually see this in the CERT main page. I've just pulled some highlights here, but basically severity means what are the consequences? We see this in CWE, for example, as technical impact, but here's a set of objective guidelines. I know that still scoring these things is a little subjective, but here I have a basis for deciding something 1, 2, or 3 on what can happen because of it. Likelihood, again, meaning how likely is it that if you ignore this, that this thing could happen and take advantage of this code. And then the cost, meaning the cost of mitigating it. It might be that I need to put a control in place. It might be that I need to refactor the code or completely restructure the code. And so I figure out from these a value of 1, 2, 3 for each category, and then we simply multiply them together. And so if we end up with a low number like 1, 2, 3, 4, then it's level 3, low severity, unlikely to happen, expensive to repair. That's my lowest thing I'm going to worry about. And if it's 12, 18, or 27, it's a high severity, it's a bad impact, it's probably going to happen. And by the way, it was cheap to block, so why did I allow it to happen? Now, the really cool thing is that CERT has implemented all this in this nifty little target diagram. And it's kind of a wonky diagram in the sense that the bullseye kind of implies something that maybe isn't there. But it's a really easy and useful item that I can see, hey, all my nasty stuff sits on the bullseye, and the stuff that maybe if I have time I should go look at sits in the yellow, and the green is the stuff that, hey, if I'm bored, I want to put new people on, I can get to it. So we'll show a demo in a moment, but just quickly so you know, for CERT C and C++, we have complete support, as I mentioned, for all of the guidelines, whether as long as they are statically analyzable. We work in a CERT-centric mode, meaning you don't have to figure out some funny Parasoft checker name and map it to CERT. While we're running, you always see things based on the CERT ID. Our checker names, our dashboards, our reports, everything is there. The map is, we have a map for you, and it basically says that, you know, CERT 123 is Parasoft 123, so it's kind of pointless. We do have this risk score implemented as well, and I'll show it to you in a few moments. But now, what I'd like to do is change over to Ricardo and let him talk to you about MISRA.
Okay, can you guys hear me?
You bet.
Oh, fantastic. Yeah, so I'm going to be talking about MISRA. Thank you, Arthur. Go ahead here and click on this. So, yeah, so I'm going to start with some exciting news about the MISRA Consortium, in that they are celebrating their 25th year of publication. So that's kudos to them. They were conceived in the early 1990s as a project in the UK government for creating guidelines in vehicle-based software. MISRA is really known for its coding standards for C and C++, which are widely used, not just in automotive, but actually in all industries: military, aerospace, industrial, rail, and medical. And the consortium members are comprised of not just automotive, which, you know, you would think, but they're really comprised of lots of different members from different other industries, also component suppliers, engineering consultancies. And in fact, Parasoft happens to be an active member. Now, the current guidelines that contain recommendations for the use of the C language is MISRA C 2012. And the current guidelines containing recommendations for the use of C++ is MISRA C++ 2008. Which is actually superseded by another standard, very popular standard called AUTOSAR C++ 14. So actually that leads me to the next slide. And oops, hit the wrong button there. The automotive open system architecture, AUTOSAR, provides a set of specifications to standardize the development of a software architecture for electronic control units. And they define an adaptive platform that is developed in C++. So MISRA C++ 2008 is based on C++ 03, which does not support critical and safety-related software. So hence, AUTOSAR C++ 14 was created, and they have been releasing their C++ coding guidelines twice a year since March of 2017. Actually, in January of last year, 2019, these two world-leading consortiums in C++ coding guidelines announced the integration of the standard into one publication. The goal is to unify these two standards so that they fully support C++ 17 and C++ 20, which is the most current. And actually, C++ 20 was just finalized in February, and it's to be officially published next month. So looking forward to that. There are also some interesting news with MISRA C 2012. Amendment 2 was released in February of this year, so just a few months ago. It's the big takeaway is that support for the C programming language version C11. So C11 is formally termed as IEC 9899-2011. And to give you some additional information, the C language standard IEC 9899-2018, C18 for short, supersedes C11. So by default, the new rules also apply to C18 as well. Now, the C11 language standard has been around for a while and has been widely adopted replacing the much older C99. Anyways, having MISRA Amendment 2 available to address the C11 language constructs offers really a much needed safeguards towards developing and releasing safer and more secure software. Amendment 2 provides additional guidelines to restrict and limit the usage of language constructs that may be unsafe and insecure. So, for example, one common cause of security vulnerabilities in the use of the standard library function system is defined, which is defined in the stdlib.h. So that's really important to be aware that here's where a lot of hackers would get into the system through that system call. So there's a new rule, 21.21, which specifies that the standard library function system shall not be used. So you will now get a violation notice if you actually code that in. Now, I'm going to cover guidelines, rules, and deviations in greater detail shortly also to kind of put things into perspective. But in addition, the MISRA C working group released a document called MISRA Compliance 2020 Guidelines. So if you want to claim compliance with the standard, there are 5 general guidelines that you need to fulfill. And good reporting and documentation is a key part of this. So Parasoft Parasoft DTP with its dashboard reporting and analytics is a perfect solution. And also it's going to be covering DTP, so you'll see it in action in a little bit. Now, I've been using the term guidelines, which the need to satisfy satisfy the MISRA standard states. So this is the definition here. A guideline can be broken down into a rule or a directive. And it's important to understand that directives differ from rules in that a directive may not be easy or possible to confirm a check for compliance. For example, MISRA C 2012 Directive 4.1 states that runtime failures shall be minimized. Well, how do you check for compliance then? The burden actually falls on the developer to ensure that that directive is satisfied. Now, rules, they can be checked for compliance by checking the source code. For example, MISRA C 2012 Rule 17.3 states a function shall not be declared implicitly. Well, easy. I can check for that and by looking at the code. In addition, every rule and directive will have a category field. So this is important because it'll contain the word mandatory, required, or advisory. And for directives, required or advisory is what you're going to find. So let's start with mandatory for when you find it in the rule. If the code is found to violate the rule, and you see that mandatory value, the code must be fixed. There are no exceptions. Now, a required value permits a deviation from the rule. So a justification must be provided, and I'll discuss deviations in actually greater detail. Now, an advisory value expresses a recommendation, but don't just go off and ignore these. They are important because they are an accumulation of years of experience and agreement by the members in the committee about the importance of these violations. So this is just a visual to show you what these rules and directives look like when you find them in the standard. You'll see they have a category, applies to, which is like the different language, C90, C99, the rationale. Some of them will have examples, like under Rule 16.3 on the right. you'll see examples, you might see ways to actually provide a solution, and there's also reference material that's provided for you to make it easier. All right. Now, the standard states that a deviation is used when a MISRA C guideline or rule is deviated for a single instance in a single file. However, MISRA does not endorse any particular method of deviation, although they do provide some suggestions. You can see that I've listed them here to clearly state that, which guideline is being deviated from. Also provide the scope or location of where the deviation is being applied, provide the justification, including safety assurance for the deviation, and also provide the consequences and mitigations that have been taken into consideration. So let's take a look at an example. So here what we see is a switch statement, which violates MISRA Rule C 2012 Rule 16.3. It states that every switch clause shall or must have an unconditional break. Now, however, the developer wants to flow into case 1 from case 0, but this triggers the violation for the rule. Now, so this is an example of an inline deviation that you're seeing here with the comment. You can see the scope, which is the location of the line of the code that triggered the violation. And you need to make sure that you capture that. The guideline or rule is also provided, 16.3. The justification follows, and then the consequences or mitigation detail, which in this case, a requirement is being referenced. Now, going back to the scope and how MISRA doesn't really endorse any particular method, with Parasoft C++ test, the developer has the option to suppress violations at the project level, the file level, the function level, the line, as you can see here. And you can also specify a section of code within a file. So really you have complete flexibility, and that's what you really want. Now, I'm going to talk about why adopt MISRA. You have probably already seen multiple graphs like I have here and heard many times the term shift left to find defects earlier when they are cheaper to fix. And yes, the cost increases as you move through each of the development phases because at the next development phase, more people have to be involved in fixing the defect. So more effort, more time, scheduled delays may take place, documentation may need to be updated, software patches may be required, and the list continues to grow. And if the product happens to go out with a severe defect, then you may have recalls, lawsuits. Basically, the cost can be astronomical. I decided to put this slide on this topic because I still find it surprising that as recent as last year when I delivered a couple of public presentations, I asked the audience of embedded engineers if they were using MISRA or some other standard to perform, some kind of static analysis. And there were still folks that were not using any kind of static analysis. They were relying primarily on unit testing. And so in one of my previous job roles, I was a project manager responsible for delivering software testing services. So unit testing, the software was always the primary request. Never static analysis. So on one engagement, after 4 months of unit testing with a team of 6 engineers, I decided to run the MISRA C standard on the code. And in a matter of like an hour and a half, 2 hours, it found approximately 85% of the same defects we had discovered during the unit testing. So imagine that, 2 hours versus this 4 months period. Also, additionally, the static analysis also found other defects that were missed during the unit testing. So my experience and message here is that if you are not applying static analysis from the get-go, your cost of testing is not being mitigated. Relying on unit testing and using development resources to do this is not cheap. So unit testing also takes longer to perform. There's more rigor to it. So the time spent and the productivity loss just compounds the problem. which is higher testing costs and even schedule delays. Adopting static analysis is so easy to do, and I mean easy. So doing a little demo, I'm going to show you just how simple this is. So anyways, we're using Parasoft C++. So there's also one other important topic here, and that is that no one testing technology is an all or nothing. It's the end all. Understand that static analysis rules are undecidable in the sense that you cannot catch all issues. So what do? You use static analysis as your first line of defense. Use runtime analysis, also referred to as dynamic analysis, to capture more defects, and then apply unit testing. These are all done by the developer in the early on implementation phase. You can also have a peer review process in place, and I'm sure probably many of you do, where you have many eyes from the development team reviewing the code and they flush out additional defects. Then the independent QA team will perform their job in doing system testing or functional and non-functional testing. And there are other details to this that I'm kind of glazing over. For example, I get asked, when do I know when I'm done testing? Well, applying structural coverage during system testing is, to me, a great indicator. So based on executing all your system test cases, the coverage results will tell you how much of the system code was executed. If only 40% of the code was executed, well, you have a lot of test cases to implement to exercise some of that code. And for the most strictest standards, like in avionics, 100% code coverage can be mandated. And that can be achieved through a combination of testing technologies like unit and system testing. Now, Parasoft C++ Test is a unified testing tool, which means that it supports multiple testing technologies within one development environment. So you can perform static analysis, unit testing, and that is on the host or hardware target for verification and validation needs. Structural code is also provided and down to the assembly or object level if that's also a requirement for you. Now, C++ Test provides a complete guideline coverage for MISRA C 2012, including the newly released Amendment 2 guidelines. So Parasoft leads in guideline coverage for MISRA C++ 2008 and AutoSAR C++ 14. And Parasoft's DTP solution with automated generated reports are ready for audits and fully comply with the newly released MISRA Compliance 2020 standard that I mentioned earlier. Parasoft C++ Test is also certified by TÜV-SÜD for developing safety critical software and supported with our qualification kit, which streamlines the process for approving the tool for use. In standards like ISO 26262 for automotive, IEC 61508 industrial, IEC 62304 medical, EN 50128 rail, and DO 178B C for military and aerospace. All right, so let's go ahead and actually do a little demo here. Let me minimize this. And I have a project. This is the Eclipse, so Parasoft C++ runs within various IDEs. And you can see how easy it is. Basically, I'm just simply going to start a project, create a project. And I already have a project on my machine. And I'm going to call this code analysis. So I'm going to use the Sigma C GCC compiler. And the next thing I'm going to do is just simply import my files so that we can start performing some static analysis. And I have some sample projects. I have various ones from embedded, security, and so I'm going to choose this flow analysis CPP. I'm going to select all the files, but leave out that make file. We don't need that. And we have now a project that's ready for performing a static analysis and unit testing. So it's that easy. So for example, I can right click on any one of these files and go ahead and start performing some static analysis. Now I'm going to do it for the entire project. So let's go here. I'll use this history again because you can see some of the things that I've run before, MISRA C 2012, 2018. But since this is C++, I'm going to do the 2008. And the other thing that I want to show you, let me see, it's going to start there, is at Parasoft up here, we actually have all these built-in capabilities ready to get you going and productive right away. So we have these compliance packs. So for example, for automotive here, if you want to do the MISRA C 2008, you can actually execute that. Or if you're, complying to standard ISO 26262, ASIL level D, it'll automatically create unit test cases for you, and you can already be very productive, have results, have some test cases out of the box going really, really quick. So we have a lot of these more built-in packs. There's for aerospace, DO 178A, B, C. You can see that we even have the Joint Strike Fighter standards for medical, FDA, security packs. There you are, CERT, CWE, OWASP, and the UL 2900. So all of this is really nice. Now, if you're building code also for running on different target environments, you can see a lot of the environments that we support, very popular, ARM, IAR, and Kyle, and all that kind of stuff. So we're ready there, and if something's missing, don't worry, we can help you make sure configure it so that it can be supported. And unit testing, again, just to touch on that, we can generate a lot of unit test cases, test suites, and get you going. So this is really fantastic stuff, easy. And you're dealing with an IDE that, you've been using. It's intuitive. You're not having to deal with some proprietary IDE and have to take training classes on how to use it and all that kind of stuff. All right, so anyways, here the results, there's 6 files been checked. There's a total of 218 violations. We can look at some additional information. Source lines of code, 236 were checked. And we can see here number of violations, rule violations were 39. And if we go to the quality task, we can see that they've been prioritized here, severity 2, 4, and 5, and we can expand these. So we can dive into any of these. Let's take a look at some division by 0. You can see here, we can also double click and it could bring up the code. So we can say, oh, okay, yep, there is a violation here. We can see the violation number, the division by 0. And so this is pretty cool. The other thing we could do is if there's some, sometimes you get noise through some violations. So we could suppress. So let me show you how to suppress that. And they're suppressed locally and suppressed in the source code. And here's where you would write, justification and reference or any of that kind of information that you want. So let's go ahead and suppress it locally, so you can see that it disappears. But you also can look at your suppressions. There it is. And if you want, you can go ahead and delete that selected suppression. Now, there's also another way that you can do this. You can suppress. Let's go ahead and let's take this, any one of these. Let's suppress the task. And we could do it in the source code. And you can see it here, just like I showed you in the slide. The scope is that line, and you have the violation, the rule number, and the deviation justification, and all that stuff. So this is what you have. So it's that easy. You can now go and fix this code and continuously run and execute and fix all until your violations are gone. If you work with ALM tools, you can also create defects and assign them to folks. It just depends on your project. Now, one other thing I want to show you here is that there are ways here to report. So you can see here it says publishing to DTP. So that's one of the things that you can do. And then you could also get this quick little report that you can view within C++, telling you the actual standard that you applied, the timestamp, there's the project, all of the violations, who the author is, and then you would also again see this in DTP, which Arthur's going to show you. So I'm actually done with this quick demo. I'm going to now pass it over to Arthur.
All right, thank you. And let me share my screen again. You should be able to see DTP now. Is that working for you, Ricardo?
Yes, I can see it.
Okay, so this is our MISRA dashboard in DTP. It's a browser-based system, so you can see things. It does pretty much what you expect dashboards to do from everything. So if I decide that, hey, these guidelines, I want requireds to be above all, and if I want to go in here and I say, hey, I want this to apply to, you know, just the mandatory category. Now I've changed that widget. I want this widget to apply to a different project from the latest build. I want it to apply to this other one from a couple of years ago, and all that sort of stuff that you're kind of used to doing these days. At least modern tools should have them. So I wanted to use the CERT C board for a moment. You can see we have a whole bunch of pre-built dashboards. You can create your own, you can clone them, you can share them, you can add widgets to them, etc. But I talked about the CERT C, so I can get here a quick at the top left. I can see, hey, I am not currently in compliance or conformance with my CERT coding standard. I can see how much my code is compliant, how many deviations I have, how many violations I have. I could get it by the status type. And here's that nifty little risk dashboard that I talked about. So let's just punch that thing and see where we go, right? So now I have my report and I see I can pick again. We talked about rules versus recommendations. So I'm going to say I only care about the rules and I only care about level 1, right? Or I only care about level 2, or I only care about level 3. So I can look at all the different things. And in fact, I can go back to all and I can say, I want to see the ones that have deviations. And so you can see that I don't have any level 3 with deviations, but if I turn everything on, I do. So it's great. It just helps me get to all the various problems. You can click on individual things. I get a conformance testing plan here. So this is normally like a big painful map that you'd have to make. If you look, you see that like CERT MEM 34C guideline is fulfilled by Parasoft CERT C MEM 34, and then we have a -A just in case there's an A, B, C, D. As you see with some of these, as I go down, some of them have multiple like sub items that could be done. So this is something you can easily give an auditor. It's great. We have a deviation report you could easily hand an auditor that shows you for each guideline. You can see most of them I don't have deviations. And off you go. And here's my deviations, who did it, when, why, etc. So that's kind of cool. And I have a build audit report because now that I've said, here's what I'm going to do, here's what I've done, this tells me when did I do it, okay, and what did I do at that time. So all the stuff you need. And the cool part about that is that normally, like when the audit comes along, this can be quite painful trying to gather this. Just the conformance testing plan, which because we work in a standard-centric mapless mode, it's mindless effort. But just trying to gather all this, we have this download PDF, and boom, you get all of those reports all in one whack, ready to go, ready to hand your auditor. Now, the other thing is you can actually work from these and start to work on violations. So I can say, hey, this red stuff over here in floating point or error handling, like I'm concerned with this heat map here. And it's now similar to what I saw in Eclipse. I can see all the different violations here of that particular guideline. And if I click on individual violations, you can see that I go right to the line of code. And over here, I can actually do interesting things. I can assign this to a different person to work on. I can suppress it or deviate on it. I can change its priority or its criticality. I can mark an action for, you know, this needs to be reviewed or this needs to be fixed. And I can set my own internal like risk as opposed to just criticality or priority. I can say this is critical and the risk is extreme for us. I can put a date on it and off it goes. I hit apply and I could, for example, assign this to Ricardo. You have to fix this now. Okay. So Ricardo's not in my system, so I can't make him fix things, darn it. But, and that's cool, right? Because it allows me to make sure that if I'm assigning things to people, it gets assigned properly. The other thing is I could have batch done this, right? I've now used my risk. I've picked the most risky things. I've picked an area that was a hot spot for me. I could bulk these. I could assign them all to somebody, and I could set them all to suppress if I want in one whack. I could change all their severities in one whack. So it's pretty cool because it lets me do a lot of things. I do have a modification history. I need to not look at all of them, but I can see when was the file changed, etc. I have a violation history. So when did this problem occur? When did it start occurring in what branch, etc. And if available, there are stack traces and the documentation, which we also saw. For each checker that we have, you'll notice again, the checker is labeled after the standard. We don't have to ask. We get that informational and normative text. We get a little C also, hey, here's a similar standard. How long it's been in the Parasoft tool. We get some notes about what is it, why is it for, what are exceptions, in other words, when wouldn't you use it, what are the benefits of it, what are some drawbacks, sometimes maybe there's a performance issue or things like that. We see examples, bad code, good code, and some references, and this is what I was talking about earlier. You can see that this MISRA rule enforces the same issue as these different CERT rules, and you actually see that there's multiple CERT items that might combine with that. So you can click on any of those and go and learn more about them in that CERT wiki that I was talking about before. So lots of really cool stuff for just, you know, some automated risk and priority capabilities so that you can get a smaller number of issues to fix, and some great ways to understand where am I at with my compliance. Am I getting better? Am I getting worse? I can look at different levels, and then some ways to even, like I said, manually triage it. We do expect that practitioners are sitting in the IDE, as Ricardo showed, and these results show up there where they can actually work on them and fix them. So with that, let me go back to my slides and hit that little present button. One other thing we just wanted to make clear, and we didn't, you know, this, it's kind of boring to demo a build integration, but certainly you want to make static analysis part of your pipeline, whether you know, it's continuous or it's just part of an automated build or a manually triggered build. But our tools are available to work in these systems through, we have plugins for certain tools, we have APIs that you can control things programmatically, and we have the good old-fashioned CLI, because man, you can automate anything if you have a CLI. So it's really cool. Sometimes we send graphics back to the systems like Jenkins where it's possible, etc. So just so you know, I really strongly believe in a trust but verify model, where what people would do is run static analysis on the desktop the way Ricardo did and just fix stuff. Don't check crummy code into the system. And then I do static analysis as part of a validation in the build. I don't expect it to be a testing technology to look for bugs. I'm looking for compliance with the standard. I expect that compliance was done on the desktop. They were supposed to run their static analysis. And now in the CI/CD system, I can say, yep, we're in compliance. So that's the most effective, most efficient way to get the biggest value out of static analysis, whether it's MISRA or CERT or any other standard. That's just the most effective way that I've seen. So a couple of final points, and then we'll take some Q&A. We've answered a few questions in the box. If you haven't popped your Q&A box up, there's certainly some things there, so feel free. If you have other questions, feel free to put them in there right now. We do have Brian monitoring things for us as well. But again, just, you know, modern embedded systems are complex and interconnected, right? There's a lot more code, there's a lot more components, and there's a lot more access. There are so many points of failure. And from a security perspective, you know, so many attack surfaces. But the upside, as I mentioned earlier on, is quality, reliability, safety, and security are all improved together. If you start using MISRA, if you start using CERT, it's going to help you. It's not an orthogonal process. It's not something that you're only going to do for security or only do for safety. It's gonna make your project better. And in fact, you know, it's funny, Ricardo was talking about doing this project for somebody where they were trying to do compliance through unit testing. And the truth is that it's cheaper just to run static analysis and stay in compliance in the first place, right? Like the earlier you catch something, the cheaper it is. So doing the right thing here might feel like it's extra work, running a static analysis tool and fixing the non-compliant violations there, but it's actually cheaper than trying to go and chase bugs late on, and then maybe it's too late to deal with them properly. So process and standards aren't enough. We saw that in one of the early surveys there about how a lot of people have a coding standard, but they don't have a static analysis tool enforced in it. I'm not quite certain how that works. So like static analysis is the way to do it. And static analysis is nice because static analysis can act as an early testing tool. So, running flow analysis rules as part of a build is an early detection capability. But these pattern-based rules that enforce engineering standards, that enforce proper construction of your code, are proactive and effective, right? They're really, really great. So, there was a couple of questions here. It looks like Brian's answering about like IDEs and platforms other than Jenkins. Yeah, and there's maybe Brian, if you could stick in the chat box a link to I can't remember where it is on the website, but there's a link to like the C++ test page that shows the integrations and stuff so that people can just get it that way. We support lots of different things and lots of IDEs and lots of plugin systems, etc. So rather than sit here and list them all, let's just do that way. Okay, so a while back, I did a white paper and a study, and there's actually a webinar about this too, if you're interested. But I talked about what are the things that we expect out of modern static analysis tools. I broke it down in these 5 categories, like configuring it, because some tools, for example, don't let you turn checkers on and off, and we actually saw that in one of the questions that we've answered here. Open your QA box if you want to see the answer to the previous questions that we just answered online as we went. But yeah, being able to create your own checkers, to change your configuration, to have inline and external suppressions, all these kinds of things. Online training. We actually have online training links that have video training for specific topics, for specific checkers. Rich reporting and compliance things where we fully support the standards. These are the things we expect tools to have. And by the way, like we're focused today on C and C++, but we do also have solutions for .NET and Java. So Brian put the link in there. It's parasoft.com/ctest/static-analysis for those who are looking for those answers. So let's see, do we have some unanswered ones still that we need to go to? Let's see, IE platforms. Brian, it says you want to answer this live. Do you want to chit chat for a minute, Brian?
Yeah, I feel like if we have time, I might as well.
Sure.
So first question, perhaps support for IDE and platform other than Jenkins. So yes, we support Eclipse and Visual Studio by default, but we also support many different Eclipse flavors and a handful of embedded environments specific, like maybe Wind River Workbench and IAR Workbench, to name a few.
Yeah, Visual Studio Code is another one.
Absolutely, that just got support for Visual Studio Code, which is great. Let's see, is there built-in rules in Parasoft for C++ core guidelines? Yes, each Parasoft tool has its own recommended rules that Parasoft recommends kind of for first time running. If you're not looking for a specific standard and just kind of want to get started with a core set of rules.
Yeah. And it looks like there was another one about violation suppressions for macros, Brian.
Violation suppressions for macros in a header file. So macro expansion works a little bit differently based on how we pre-process things. It depends on where the violation is actually triggered. If it happens to be on the first line of the source file after header expansion, then the suppression does have to be triggered in the source file after pre-processing.
Right. So it's a little nuanced. If you have specific questions on that, the James who asked, like, feel free to send us some info and we'll get in touch with you and like walk through the various nuances on how to get the most out of it. So let's see. It looks like I guess we can mark these as answered now. So that's great. So we're at the clock anyway. I did want to mention one other thing before we go today, which is, you can follow us. We're on Twitter, YouTube, Facebook. We got some really great new videos going up on YouTube all the time now. I mean, you might not be used to following us on YouTube because we didn't used to do a lot there, but we actually have a lot of cool stuff. We're active on LinkedIn. We post about these webinars. You can always send email to us, info@parasoft.com, but feel free to follow us in these places. And, we're doing lots of webinars right now where everybody is really sheltering in place, and we appreciate you joining us. We have a couple of different tracks, one around functional testing that we do on Tuesdays, and this focus on embedded and safety critical on Wednesdays. Next week, we'll be doing learn how to shorten time to market for new medical devices. So that'll be great. Hit that link there. I'll paste it into the thing in a moment, but you can always just use your phone and hit that QR code we've got there and just sign right up for that thing. And if you've got specific topics that you'd like to see covered, please let us know at info@parasoft.com. We'd be happy to cover some things for you and make sure that you know about them in the future. So, Ricardo, any closing messages for us?
No, just thank you for attending. Stay healthy and safe out there.
All right. Thanks, everybody, and have a really great day.